tours of the facilities. So our next speaker is going to be Dr. R. Kent Clark. He is a professor of physics at the University of South Alabama and the editor of the Journal of Double Star Observations. So many of us are probably quite familiar with them.
Okay, thank you. Okay, well, I'm going to start out by just introducing the Journal of Double Star Observations. Maybe there's some people here who are not familiar with it. And I'm going to briefly talk about some of the tools that authors have used, that people who have published in the journal, what type of things they've done to make their measurements, and then talk about, in the observation techniques thing, I'm going to talk about each way people measure double stars, but also introduce some of the authors of papers, good stuff, that people who couldn't be here today. So the Journal of Double Star Observations is an electronic journal. You can get it off the web at that URL there. Some years ago, I had some students. I'm a professor of physics. I really consider myself an amateur astronomer. I had a bunch of students come to me and they wanted to do an astronomy project. And so we did a little project measuring a double star in the constellation Cassiopeia, and they did some work to with their measurements and with the historic measurements of that star. They did some work figuring out that the proper motions, and that it was not really that it was not a gravitationally bound system. They gave some talks at conferences, wrote it up, nice paper, and I was going to submit the paper to the Double Star Observer. That was published by Ronald Tanguay, and that's about the time he quit. And so I said, "Oh man, this really left. We had a nice paper, no place to send it, but I could see that, we're not the only people in the world doing this. I could see there was kind of a hole that was left behind when Tanguay quit. So I said, okay. I called up Rod Melise, who is a prominent amateur in Mobile, and I talked to Brian Mason, who is very helpful, and we started publishing the JDSO in April of 2005. Each journal I start a new volume on January 1, so we're now in volume 9. Been 258 total articles published in that time. Most of the papers are, of course, measurement papers. Some papers, authors get into talking about new techniques that they've used to publish it. A few authors have gone into more than just measuring position angles and separations, or measuring properties of doubles themselves. Sometimes people get into the history aspect of it, which is kind of fun papers too. All right, tools of the trade. We've already mentioned this thing. This is the Astrometric eyepiece is used mostly by the student observers. And I should say that most of the authors in the JDSO are amateur astronomers. There's occasionally been a professional astronomer that has submitted a paper. Usually that's in collaboration with some of their students that they have worked with. And a lot of times the students, as mentioned earlier, they use this eyepiece because it's so cheap. This is an oldie goldie here, I guess. I don't know. There's only one. The project that my students did, they used events like Micrometer, like this one. And then I know of only one other author in the JDSO that uses a Micrometer. You may have seen it in the slide that Joe showed earlier of Dave Arnold, who uses one. They're nice. They have a short learning curve. You can make fairly accurate measurements, but if you get one made for you like this, it's very expensive. You just as well buy yourself a CCD camera. Although there's something to be said for you've got to put your eyeball on the eyepiece to make the measurement, and especially for student-oriented projects, I kind of like this. I'm fond of it. I think, Russ, are you still in the market? Weren't you in the market for one of these earlier? Did you? Okay. And then, of course, the instrument of choice is the CCD camera, where you can do ever so much more than just double star measurements, and that's probably enough said about that. All right, so I'm going to talk some techniques. All of these things, in one way or another, are going to involve a CCD camera, and highlight some papers that have been published in the JDSO using these things. This one's kind of unique. We know that double stars that have a high difference in magnitude can be problematical for making measurements. James Daly here has published several papers in the JDSO. He has come up with what is literally a baling wire and sticky tape solution for the problem. He taped a thin strip of aluminum to this plano convex lens that he put in his optical system to occult the bright primary so that he could make it easier to see the secondaries, and been very successful with it. This is an image that he took of Vega. The C and E companions I know are 11th magnitude objects. The bright slash that's diagonal across there is the aluminum strip. And oddly, even though the aluminum strip's there, the central portion of the star still comes through, which he finds very useful when you start wanting to make some PA and SEP measurements, that is there. Some people put a webcam on it. Wolfgang Vollmann has done some with webcam. He's got a Philips 2U cam, so he's got this cheap webcam. He sticks on a really nice astrophysics refractor. With a 3 times Barlow, he can achieve a resolution of 0.325 arc seconds per pixel. Now, which I think is rather remarkable when you got a chip that's 640 by 480. But of course, he's got a very small field of view, so he's got to take some care to get the thing aimed correctly. So he'll take a movie, and then I think he used Registax to pick out the best of the frames that he had, and then Florent losses reduced to make the measurements. And he does pretty good. This is some measurements that he took of 70 Ophiuchus over a period of years. Measurements that are up there are his 2010 measurements, and you can see he's got about a 1% uncertainty. Those are his standard deviations for his uncertainties. And he overlaid those measurements on an orbit from the 6th orbital catalog just to see how well he was doing. Now, a DSLR, one thing about DSLR, I mean, it's a CCD camera, but it's kind of fun because you can buy one for vacation and then get a T adapter and stick it on your scope, and you start making all kinds of measurements with that, and you don't even have to take that little pesky infrared filter that's there on most of them off, because we're doing double stars. We're not worrying about doing low contrast red nebulae. Erno Burko, I think I'm pronouncing his name. I'm sure I'm not pronouncing it. He's a Hungarian. Berko, thank you. He is a measuring machine. He takes his DSLR and he has submitted some papers with literally hundreds of measurements in them. He's got a Canon EOS 350D that he puts on his Newtonian reflector, and you can see he gets 0.3 of an arc second per pixel. And this is just a couple. He has lots of pictures in his papers. This is one that he has of 2 of the stars that he measured. And I don't remember. I think the separation on these was around 15 arc seconds or so. This is a recent paper from another person who uses a DSLR camera, Michel Michaud, I think. Used DSLR camera to look at the Pleiades, and he has this image. This is one of the images that he used, one of the double stars that he used, with a separation of about 5 arc seconds there. Edgardo Massa Martin uses a DSI Pro, which is no longer made. It was a cheap CCD camera that Meade was making. I don't know. They switched to DSI 3, and I'm not even sure they make that anymore. This is a picture of his observatory and his telescope. It's an 8-inch Newtonian that he would put that camera on and make measurements. He got about 0.4 of an arc second resolution. Did pretty good. Meade said DSI stands for Deep Sky Imager, but I decided it ought to be Double Star Imager. This is this paper was from a group of Romanian astronomers. There was one professional in the group who is on the staff at this Astronomical Observatory of Natural Science Museum. They used a big Santa Barbara CCD camera to do their measurements. They had a 16-inch Ritchie-Chrétien telescope. We're going to hear some more, I think, about lucky imaging. Rainer Anton in Germany, he's a retired physics professor, has done a lot of lucky imaging papers, does really, really well. He also a lot of times goes down to Namibia and images southern hemisphere doubles. These are from that paper, and you can see he's resolving doubles that are like a half an arc second separation. It's really remarkable what he can achieve with this lucky imaging. This is a paper where he looked quite a bit at the accuracy that he could achieve. Over on the in black on the left, the double humped is a luminosity scan of this image here. This is of a double star Beta Phoenici, and this image was made on a 50 centimeter Cassegrain, which I think was down in Namibia. He takes literally thousands of pictures with his camera, and then picks out just like the top 2% that happen to be taken, and he's using, depending on the star, anywhere from just a few milliseconds up to half a second exposure. Anyway, that double peaked one is of this thing. The red one that looks very Gaussian is what he would have seen had he just taken a 1/3 second exposure and without doing any lucky imaging. And so you can see he did really well by doing the lucky imaging and got a separation measurement of 4/10 of an arc second. He had a resolution of about 1/10 of an arc second per pixel. We're going to hear more about occultation, so I'm not going to talk a whole lot about it, except I think it's kind of cool when it happens. These guys discovered a new double star from an asteroidal occultation, and of course the thing to look for is a double step function, as the asteroid or the moon, whatever, occults first one star and then the other, and then the double step function on the other side as they become uncovered. This picture from that same paper shows an outline of the asteroid. They had several observers, and overlaid on that outline right here is a kind of a representation of the double star with the appropriate position angle and separation to scale. And I think it's rather remarkable. It's a neat technique. You can see the separation here is 6.5 milli-arc seconds. It's incredible, with about a 17% uncertainty. The problem, of course, is it's a one-shot, but it's still pretty neat. We're going to hear a lot about Speckle Interferometry too. We already have heard some. So far, I have only just this one paper on Speckle Interferometry. I'm hoping for more. This is a pretty sophisticated technique, so it's something hard, I think, for a lot of amateurs to adapt, because you've got to do you're doing all kinds of Fourier transforms, so it takes a lot of work. I think the remarkable thing about this paper was that it was done on a webcam instead of so it's pretty cool that he did that. Data mining. I'm ambivalent about data mining. It can be done poorly, and I've been burned by that a couple of times. And also, I think sometimes we forget when we're data mining the work that the people did to get the data. Excuse me, I'm apparently not coming through. How's that? It won't stay. I'm not wearing it right. Oh, there we go. Now we're good. All right. To me, it's kind of a Kepler-Tycho thing. Kepler wouldn't have been anywhere without Tycho first getting all those measurements. And not that Kepler didn't do anything good. He did, but it wasn't just him. And like I say, it's easy to write a program, run it through the catalog, look for stars that are nearby, and claim them to be a double, and not think about it too much. But Rafael Caballero did it right. This paper, because I'd gotten burned in the past on these kinds of things, I sent this thing to 3 different professional astronomers for review, and they all thought he did a good job. Of course, he had to make some changes, but and I know Rafa appreciated the reviews too, and it became a really good paper. I really like these kinds of pictures where you got pictures here of these double stars that were taken 36 years apart, and you can actually see how they are moving through space together. That's the steps that Rafa went through to make sure that he had real physically associated binary stars as close as he could be. He started with he just went through the NOMAD catalog, applied Haubach's criteria, which is a statistical test of the stars to make sure they are, comparing their separation with their proper motion to make sure they are actually binaries. That got him down to 600. Checked against the latest WDS, that eliminated some more. Checked to make sure that both stars were listed in one of these 2 catalogs. That eliminated a bunch, and then he actually went and eyeballed them. He didn't do it at the telescope. He looked at them with the Palomar sky survey images. That eliminated a bunch because he found that things like galaxies or something like that was in there. And then the remaining 111 he measured using 2 mass. All right, I've got to say something here I've kind of debated about, but it's something that's I've kind of concerned me a little bit. Rafa did a great job. I say I'm ambivalent, but I really admire the work he did. But he never put an eyeball on a telescope to look at what he was doing. And it kind of concerns me that, you know, it's the rise of the robots kind of thing. We've got all kinds of robotic telescopes out there that can do everything. You just program it up, it does it all for you, sends you the data. And now the software is getting good enough. Will there come a time when we can go through the entire WDS, and or at least the physically interesting stars in the WDS, in say just a few years, say a couple, 3 years, and they don't need to. We won't have any neglected double stars. We won't have, it becomes a monitoring thing. So I'm throwing that out there just to try to generate a little discussion, maybe some panel discussions later on in the conference, something to think about. Where are we going to be with this field in a few years? But that day's not here yet. And if it does come, we can still have fun looking at double stars and measuring them ourselves. And so I want to publicly thank the contributors and the readers and the referees and the supporters of the JDSO, and I thank you all for listening.